Good morning, everybody. I hope you're having a good, great, grand, wonderful day. Guys, it is week 5 of distance learning. We are almost done. All you have to do is make it through this week and next week, and we get to call it. For those of you who are not caught up, then you get a couple more weeks to try to get your stuff caught up and get your stuff done and all those things. But everybody else can be done by this next Friday, and that's kind of cool. All right, well, great news. We get to finish the year with some of the easiest stuff that Trig has to offer. And it's very different than everything we've done before. So this should be kind of interesting, a little bit different, a little bit crazy. But what we're going to do today is we're going to start with something very easy, and it's called the law of sines. The law of sines is unlike anything we have done so far in Trig. And you might think that I'm just kind of saying words or sounding crazy, but the law of sines is completely different because first and foremost, it has nothing to do with right triangles. And that's kind of crazy because everything in Trig has to do with right triangles in one way or another. But the law of sines has nothing to do with right triangles. And that's why this triangle right here that I've drawn is not specifically a right triangle. It may be, but it doesn't even remotely have to be. Okay? And the law of sines is an incredibly simple thing. It just says that if you take the sine of some angle in a triangle and compare it or make a ratio to the side opposite of it, that will be equal to the sine of any other angle in the triangle when compared to the side opposite of it. And that will be equal to the sine of any other angle in the triangle when compared to the side opposite of it. And so all it is a proportion. Now we can make it have 3 parts, but that looks a little confusing. So I'm just saying that each one is equal to the other. So now thinking about the laws of proportions, you can also flip this. And so it would be the same to say that little a, which is the length of the side, is to sine a in the same way that lowercase b is to sine b. That's the same. You can take a proportion, you can flip both sides, and it still remains true. And so that's it. That is, in its entirety, the law of sines right there. That's everything. So let's talk about how we're going to apply this, how we're going to use this. I've got 2 quick examples that we're going to walk through, and then I just want you to practice this a little bit before we do some really cool stuff with it. Okay, I want you to understand how the law of sines works. So, exemple numero uno, here we go. All right, and so I've got this triangle set up, and you notice we're missing 2 sides. We don't have A, we don't have B, and we're also missing an angle. We don't have angle C. Now, good news, we know that if we've got 2 sides of a triangle, 2 angles of a triangle, we know we can get that third angle because the 3 angles have to sum 180. So we can take a look at this and we say, well, I know that 32 plus 85, well, that adds up to 117. And so then I can take that 117 and subtract it from 180, and what's left over is 63. And those are all degrees. Okay, and so we know, therefore, the measure of angle C has got to equal 63 degrees. That's pretty simple. Okay, so that's what we know going on. But the problem asks us to find the length of A and the length of B. Now, we had to do this, we had to find the measure of angle C to do that. We have to find every part of the triangle to kind of be able to find every other part. So now let's go for it. Well, the law of sines states that the sine of A, or of angle A, is to lowercase a as the sine of, we'll say C, is to lowercase c. And so there's my formula that I'm going to work from. And now I just plug everything in. And so I look and go, what's A? A is 32 degrees. So that means the sine of 32 degrees is to A, which I don't know, in the same way that the sine of C, the sine of angle C, which is 63 degrees, is to, and I know the measure of side C, and it's 9.7. Okay? Now, before I start plugging and chugging with the calculator, I want to do all the algebra and then make the calculator the last step. So to solve this, I would simply cross multiply. And that would mean that A times the sine of 63 degrees, so I cross and multiply these two, is equal to 9.7 times the sine of 32 degrees, and I multiply these two. And then to get a by itself, you just divide both sides. That is a terrible S. You divide both sides by the sine of 63. These cancel out. So therefore, the length of A is equal to 9.7 times the sine of 32 degrees divided by the sine of 63 degrees. And now I can use my calculator and say, notice everything is in 2 sig figs in this situation. So I'm just going to keep it that way. So I go 9.7 times the sine of 32 degrees divided by the sine of 63 degrees. Close my parentheses. Hit enter. And I get that it's about 5.769000253, so on and so on. And so in terms of 2 sig figs, that would make 5.8. The 6 would cause the 7 to round up. And so it's about 5.8. So A is about 5.8. Now, I don't want to use that number to find B. I can't use the Pythagorean theorem. This is not a right triangle. It's clearly not a right triangle. It doesn't have a right angle in it. But I don't want to use that 5.8. I want to go back to the cleanest numbers I have. And the cleanest number I have is this 9.7 right here. So I'm going to do basically the exact same problem again, but this time I'm going to set up for B. So I'll say the sine of B is to lowercase b in the same way that the sine of c is to lowercase c. And then I can plug in all of the things that I have. That means that the sine of b 85 degrees is to lowercase b, which I don't know, in the same way that the sine of c, which sine of c was 63 degrees, is to that 9.7. I cross multiply and solve, and so that would be to say that b times the sine of 63 degrees is equal to 9.7 times the sine of 85 degrees. I multiply these, and then I got to divide both sides by that sine of 63 degrees. So therefore, that would leave me with that b is equal to, not just about, but b is equal to 9.7 times the sine of 85 divided by the sine of 63. So therefore, b is about, I'm going to grab my calculator, say 9.7 times the sine of 85 degrees, and divide that by the sine of 63 degrees. Okay, and I get it's 10.845137884. And so I go, well, what is that? Well, that's about 10.8. And there you have it. So b is about 10.8, and we've solved the problem. We know what a is about 5.8, and b is about 10.8. Now, the fact that they're both 0.8 is just completely arbitrary and luck. It's, coincidence. It's not that they'll always end up that way. And so that just happens to be how this problem worked out. All right. Well, let's make sure that there's nothing here, nothing about this that you don't understand. So I'm just going to do one more example that's going to be virtually identical to this one. Okay, so one more example. Went ahead and drew so this is exemple numero dos. Went ahead and drew a obtuse triangle. And the other thing that I changed was I changed it also. It's all in 3 sig figs. Okay, so we're gonna solve a little bit more precise on this one. Okay, and so I've got x and I've got y. That's what I need to solve for. I don't have angle z, so that's where I need to start. I've got to figure out this angle right here. Angle z is the first thing we're gonna need. Okay, and so I've got 19 degrees and 25 degrees, and I add those up and I get 44 degrees. And I say, okay, so now I got to take the 44 from 180, and when I do that, I get what, 136 degrees. Is that right? Huh, that's right, 136. Whew, that is a very obtuse angle. Okay, and I can get started. I know that the sine of z is to lowercase z in the same way that the sine of x is to lowercase x. And then I can substitute in all the values I know. Therefore, I can say the sine of angle z, well, we figured out that angle z was 136 degrees, is to z, the length of z, 24.7, in the same way that the sine of x, now x is 19.0, is to the unknown x. Now I cross multiply. So I get x times the sine of 136 is equal to 24.7 times the sine of 19.0. And then I have to divide both sides by the sine of 136. Okay, and these would cancel out. And I get that x is equal to 24.7 times the sine of 19, or 19.0, divided by the sine of 136. So therefore, x is about, and I grab my calculator, say 24.7 times the sine of 19 degrees. Now, if you're using a phone as your calculator, you're going to have to do like 19 and then hit sine, and then say times 24.7, and probably write that number down, and then type in 136 and then hit sine and write that number down. Then you'll have to divide them. Okay, let's see. I started talking before finishing this problem. Divided by sine of 136, and I get 11.576242202, so on, so on, so on. And so that's about 11.6. All right, so x is about 11.6. So let's figure out y. All right, well, I set up the same way. I say, well, I know that the sine of z is to z in the same way that the sine of y is to y. And I set this one up. I said, well, sine of z, well, what is that? Well, I know z was 136 degrees. And z is 24.7 is equal to the sine of y. Y is 25.0 degrees over y. Cross multiply, and I get that y times the sine of 136 is equal to 24.7 times the sine of 25.0, and divide both sides by the sine of 136. I mean, this is basic math here. This is basic pre-algebra. You get y is equal to that right there, that 24.7 times the sine of 25 degrees over the sine of 136, which is about. And so I type my calculator, 24.7 times the sine of 25 divided by the sine of 136. And I get it's about 15.027057. So in terms of 3 sig figs, because I'm keeping everything in 3 sig figs, I get it's about 15.0. And so there's my answer. All right, x is about 11.6, y is about 15.0. I hope this has been helpful. Try these 5 problems I have for you. Look over the answer key. If you're struggling at all, please email me some questions. Come to tutoring from noon until 1. Give me a call, something. I want you guys to get this. It's just too easy not to get. All right, we'll talk to you later.